17 in section 11.6. Okay, and it says, estimate the magnitude of error involved in using the sum of the first 6 terms to approximate the sum of the series. Okay, the sum of n goes from 1 to infinity of -1 to the n plus 1, and then this is 0.05 over n, 0.05 to the n. And they want you to estimate the magnitude of error. Involved in using the sum of the first 6. Okay, and so remember we had a formula that really told us that if you have an alternating series that passes the alternating series test, the sum of the first n terms approximate the sum of L of the series with an error whose absolute value is less than the next term. So it's the first unused term, right? So if we just, do we agree that this is a, can we say that this passes the alternating series test? Well, 0.05 to the n is a it's 5/100ths to the n, right? And so then that is a geometric series, and it's multiplied by a harmonic series. I wonder if do we feel pretty comfortable that that is going to converge? Let's see. We probably need to look at the I'm not totally for sure that this is going to converge. It feels a little bit, I'm not just totally sure. So let's look at the alternating series test. So we'll verify this converges with the alternating series test. The first condition is that the u sub n's are all positive. I did see some n before, but and that should be okay because you can tell that this 0.05 to the n over n is going to be positive, so that's good. Now we want to know, is u sub n plus 1 less than u sub n, or is u sub n greater than or equal to u sub n plus 1? And so in order to determine that, we want to look at u sub n plus 1 over u sub n. So let's consider u sub n plus 1 divided by u sub n. So that's going to be 0.05 to the n plus 1 over n plus 1 divided by 0.05 to the n over n. And when you flip that, you get 0.05 to the n plus 1 over n plus 1 times n over 0.05 to the n. And you can think of this as 0.05 to the n times 0.05. So this is 0.05 n over n plus 1. And so this reduces, like this is like 0.05 let's see, this is going to be as n goes to infinity, this is definitely less than 1. Do y'all agree with that? Because it's 5/100ths. And so it must be true then that the denominator was larger than the numerator, right, in order for this to go to a number less than 1. Otherwise, if the numerator were larger, then this would go to a number greater than 1. So this is true that u sub n would be greater than or equal to u sub n plus 1. And then the third thing with the alternating series test is that you have to make sure that the limit as n goes to infinity of 0.05 to the n over n, well, that limit, that's 5/100ths to the n times 1 over n. And I mean, hopefully, if you're having a good day, you should see that that goes to 0. So it does pass the alternating series test. So it converges by AST, and our error will be at most the absolute value of u sub n plus 1, where n is the number of terms we add. So finally, here they added, 7 terms? What would they say? Here it's the first 6 terms. So here, n equals 6. So u sub 6 plus 1 is going to be -1 to the, so this is u sub 7. So this is going to be 7 plus 1 times 0.05 to the 7th over 7. So let me get my calculator here. So you're going to do 0.05 to the 7th divided by 7. And they say, use scientific notation, use the multiplication symbol on the math palette as now needed, round to 3 decimal places. So it should be 1 point, I'm sorry. That was really little. It's weird that it was so little. Okay, 1 point, what'd they say? Round to 3 decimal places. So 1.116. And then you do the times on the math palette, and then 10 to the -10. And they like that one. So on your computer screen, you write that, on the 0.116 times 10 to the -10. That's what you have to type, and you have to use the X on the math palette. Okay? Did that help a little bit? It's kind of like you could have skipped all that part about me verifying that it's converged, because they didn't, obviously they didn't ask you whether it converged, and you couldn't approximate the magnitude of the error if it didn't, but it was a nice review of the alternating series test anyway.